If you're still declaring variables with var in your JavaScript code, you're opening the door to confusing bugs, unexpected behaviors, and endless frustration, often without even realizing it. Imagine spending hours chasing down a mysterious bug, only to discover it was caused by a variable that leaked out of a loop or was silently overwritten somewhere in your code. That's the hidden danger of var. In this tutorial, you'll discover exactly why var is a ticking time bomb in modern JavaScript, and how switching to let and const can instantly make your code safer, easier to understand, and far more robust. You'll learn how var behaves differently from its modern alternatives, how its quirks can lead to accidental global variables and scope confusion, and how tools and best practices in today's JavaScript ecosystem help you write bug-free code. Whether you're maintaining legacy code or starting a new project, understanding the pitfalls of var and how to migrate away from it will save you countless headaches and give you the confidence to tackle any JavaScript codebase with ease. Don't let outdated habits slow you down. Subscribe now for more high-impact tutorials that keep you ahead of the curve and help you write world-class JavaScript every single time. Imagine you're building a house. You want your walls to be strong, your doors to open only where intended, and everything to be predictable. Now, picture JavaScript's var keyword as an old, creaky door that sometimes lets the wind in where you least expect it. For nearly 2 decades, var was the only way to declare variables in JavaScript, but its behavior is tied to an older era, and it comes with quirks that can undermine the structural integrity of your code. The first foundational concept to understand is scoping, where variables live and who can see them. With var, variables are function scoped, not block scoped. This means that if you declare a variable inside an if statement or a for loop using var, that variable is actually accessible anywhere within the entire enclosing function, not just inside the block where you declared it. For example, if you declare var x error 10, inside a loop, you might expect x to exist only within that loop, but in reality, it's available throughout the function and even outside the loop. This can lead to accidental overwrites, where one part of your code unexpectedly changes the value of x somewhere else. Modern JavaScript introduced let and const, which are block-scoped. This means they only exist within the curly braces where they're defined, just like you'd expect from most modern programming languages. This shift transforms your code into a house with clearly marked, secure rooms. Variables stay exactly where you put them, and you don't have to worry about someone opening a door halfway across the house and changing your valuables. By relying on var, you risk introducing subtle, hard-to-find bugs where variables mysteriously change or leak into places they shouldn't. Block-scoped variables, let and const, are like locked doors. They keep your data safe and compartmentalized, making your code more reliable, readable, and maintainable. So, when you think about choosing between var and its modern alternatives, remember, in software construction, clear boundaries are your best defense against chaos. Let's focus on hoisting, a characteristic of JavaScript variable declarations that often causes confusion. Hoisting is like a magician silently moving your variable declarations to the top of their scope before your code runs. But with var, there's a twist. Declarations are hoisted, but initializations are not. This means that if you try to use a variable before declaring it with var, you won't get an error. You'll get undefined. For example, if you write console.log a, var a, bacter5, JavaScript interprets this as if you had written var a, console.log a, patra5. The result is that console.log a outputs undefined, not an error. This silent behavior can mask bugs, especially in large code bases. By contrast, let and const are also hoisted, but they exist in a so-called temporal dead zone, TDZ, from the start of their block until their declaration is evaluated. If you try to access a let or const variable before its declaration, JavaScript throws a reference error, a loud immediate signal that something is wrong. This behavior acts as a safety net, catching errors early and making bugs much easier to find and fix. Think of it as an alarm system that immediately alerts you the moment you step out of bounds, instead of quietly letting you wander into trouble. Hoisting with var is a relic of JavaScript's early days, and its forgiving but dangerous nature is one of the main reasons it's been superseded by let and const. Using these modern keywords helps your code behave more predictably, making it easier to debug and maintain. When it comes to variable declarations, immediate and clear feedback isn't just helpful, it's essential for building robust, error-free applications. Let's examine our main logic file, which demonstrates the impact of using var compared to modern let and const declarations. This file contains two versions of a function, process items, each showcasing the difference in variable scoping and closure behavior inside a loop using asynchronous code. First, the problematic code uses var in a for loop with a set timeout. Because var is function scoped, all closures share the same I, leading to unexpected output. Then, the refactored code replaces var with let, which is block scoped, ensuring each closure captures its own copy of I. This resolves the bug and delivers the correct behavior. Additionally, the file demonstrates the consequences of omitting a declaration keyword, leading to accidental globals, another pitfall of legacy JavaScript practices. Finally, the examples reinforce best practices. Always use const by default and only use let when reassignment is necessary. By walking through these side by side, you'll quickly see why abandoning var is essential to writing robust modern JavaScript. This supporting file implements a utility function that often exposes the difference between var and let in callbacks and closures. The makeincrementers function returns an array of functions, each of which should increment a captured value. If implemented with var, all incrementers will close over the same variable, leading to incorrect results. With let, each closure works as intended. This example makes it clear how using var inside loops is a common source of closure bugs and how let solves the issue elegantly. The code is structured to be easily testable, allowing you to observe the difference directly. The configuration file below ensures your codebase enforces modern JavaScript best practices and prevents the use of var. The package.json defines the project metadata, dependencies, and scripts for starting, testing, and linting your code. ESLint is included as a development dependency, and the lint script will run ESLint across your source files. This setup, combined with a proper ESLint configuration, not shown here, will help automate the enforcement of using let and const only, making it easy to transition your team or project away from legacy JavaScript patterns. The demonstration begins on a web app that visually teaches why using var in JavaScript can lead to bugs, walking through a series of interactive tabs and hands-on examples. The page scrolls to reveal the heading and introductory content, setting the context for the upcoming interactive activities. Next, the Closure and Loop tab is selected. Here, the first interactive example focuses on one of the most notorious pitfalls of var, its behavior inside loops. By running the run var demo, the demo shows a for loop where var is used to declare the loop counter. The output reveals that every callback logs the same, incorrect value, typically undefined, or the final value after the loop, illustrating that all closures capture the same reference to I. This is a classic demonstration of how var is function scoped, not block scoped, leading to unexpected results in asynchronous code. Then, the let variant is run by clicking Run Let Demo. Instantly, the output changes. Each loop iteration correctly logs the intended item. This visually confirms that let, being block scoped, provides a unique binding for every iteration, eliminating the bug seen with var. The demonstration moves to the Hoisting tab. Running the Run var demo highlights how var declarations are hoisted and initialized as undefined. The output shows that accessing the variable before its declaration does not throw an error, but instead yields undefined, potentially causing subtle bugs. When the Run Let demo is triggered, the contrast is clear. Attempting to access a variable before its let declaration triggers a reference error due to the temporal dead zone, enforcing safer coding practices. Switching to the Scope tab, the demo compares the scoping differences. Running the var example shows that a variable declared inside a block, like an if statement, with var still leaks outside the block, making it accessible in the outer scope. When the let demo is run, the variable is confined to the block, and accessing it outside results in an error, demonstrating the predictable and safer block scoping of let. The redeclaration tab is next. The var example is run, showing that the same variable can be redeclared within the same scope without error, silently overwriting the previous value. This can easily introduce bugs when variables are unintentionally reused. In contrast, running the let version attempts to redeclare a variable in the same scope and immediately triggers a syntax error, catching mistakes at the earliest stage. Moving to the Accidental Globals tab, the first demo illustrates how omitting a declaration keyword with var, or entirely, inside a function causes a variable to become global, polluting the global namespace and leading to unpredictable side effects elsewhere in the code. Running the second demo with let shows that undeclared variables result in a reference error, helping prevent accidental global pollution. The demonstration continues by scrolling to the common pitfalls with var gallery. Each pitfall card is brought into view one by one, with a pause at each to highlight examples such as scope confusion, hoisting surprises, redeclaration issues, and accidental globals. This provides a rapid-fire summary of real-world bugs that var can introduce. Next, the scroll brings the comparison table into view, visually contrasting the features and safety of var, let, and const. The table highlights differences in scoping, hoisting, redeclaration, and reassignment, reinforcing the advantages of modern variable declarations. The demo scrolls further to the Best Practices for Bug-Free JavaScript section. Each best practice, like using const by default, declaring variables close to usage, and never using var in new code, is highlighted in sequence, emphasizing actionable steps for writing safer JavaScript. The focus shifts to the Enforce with Linting section, where the demonstration shows how a linter can automatically detect and flag any uses of var. By clicking to reveal the lint result, the output displays the linting errors pointing out each var occurrence, making it clear how tooling can help enforce modern best practices. The lint result is then hidden. Finally, the scroll moves to the footer, which encourages viewers to ditch var for good and embrace let and const for reliable modern JavaScript development. The demonstration concludes with a final pause, reinforcing the message that moving away from var is both straightforward and essential for bug-free code. You've just seen how ditching var sharpens your JavaScript, wipes out sneaky bugs, and gives you code that's easier to read, test, and trust, whether you're building a new app or wrangling a legacy monster. Every time you reach for let or const, you're saving yourself hours of debugging, making your intent crystal clear to teammates, and leveling up your engineering reputation. If you want all your JavaScript to just work, swapping out var isn't optional. It's the upgrade your future self will thank you for. Now, imagine never tripping over scoping gotchas or accidental globals again. That's the daily impact. Want to keep mastering these essential patterns with real-world examples and actionable tips that actually stick? Subscribe now, because every video here is designed to speed up your learning and transform you into the developer others rely on.